In this session, let us think of starters again, continuation of starters. Like here one beautiful interview question is there. Okay, I'll tell you, just stay tuned. You see here about direct online starter, we got some equation, and resistor starter, we got some equation, and then reactor starter. Okay, now if I have reactance like this, okay, so in this, if I keep reactor and this is going to be, so I can reduce voltage or not? Yes, stay tuned. Okay, means very good question. Now this is stator, A can be connected to here, B can be connected to here, C can be connected to here. Okay, now if I supply, let me complete this, and at the end I will ask you the question. I will tell you the question. So for example, if I supply rated voltage line here, okay, so here rated voltage line will come here, across this, drop will be there, in the reactance can be used because it is AC. If it is DC, only DC machine, DC motor starters, only resistance will be there, but here reactance also can be there. So this is going to be X times rated voltage line. Okay, so this is going to be X times rated voltage line, means that this is going to be X times rated voltage phase. Means that current flowing through this should be, if I supply rated voltage in phase, current flowing is ISC. So if I reduce the voltage, it will be X times ISC. Current will be reduced, and see here, this is going to be X times ISC. So here current will be reduced to X times ISC. Okay, now again, just wait. Now for example, T starting by T full load is related to only motor. Okay, so is going to be, how much is this? Current is in phase. This is meant for the source, this is meant for the starting torque of the motor. So it is going to be X times ISC by IFL square into SFL. So this is going to be X square into ISC by IFL square into SFL. So means torque is reduced by X square times, but source current is reduced by only X times. Okay, so only X times. Now point here is, there are two things. First thing is, first interview question is, do you prefer reactor starter or resistor starter? Okay, so which is better to use? Now you may think that resistor starter is lossy. Okay, reactor starter is lossless. So let us prefer reactor starter is wrong, because we are not going to play with the machine. No, for example, if you go to a farmer, okay, so farmer, what he will do, he will switch on his motor and go and do his work. For example, in your at your home, maybe ceiling fan might be there. So what do? You are going to switch on and do your work. Okay, so you are not going to play start stop. No. Now power loss doesn't matter here, because for example, if it is with resistor, what could happen, during starting only resistor currents will flow. So during starting only some power loss can happen. Okay, so starting power loss doesn't matter, because my machine is supposed to be working under running conditions, stable conditions most of the time. Okay, so starting condition, for example, if you switch on any motor, maybe for hours together or days together, it can work by having only starting only once. Okay, so just we should not think of starting losses, but we have to think of the cost of the machine combination. Okay, for example, resistor, it's take some nichrome wire and do it, that is going to be resistor. Okay, so resistor, for example, if I replace this with resistor, it is cheap in the market. Okay, but if you think of reactor, it's not analog electronics reactor kind of network theory reactor, just take a copper wire and do it, this is reactor. No, that reactance value is much less. Okay, so how to maintain reactor in machines? Again, you should have iron core. Upon the iron core, you should have windings. This is inductor here. Okay, in machines. So copper wire should be there, and iron should be there, and that iron should be laminated. laminated. So it means in order to cool down that, like transformer oil should be. In order to, we have to keep transformer oil, so we have to fill this with transformer oil, and in order to cool down that transformer, kind of transformer, vane should be there. How much costly it is, okay? So in practical application, resistor starter only we are going to use. We normally, if duty cycle is less, for example, multiple times, if you have to start the motor, stop the motor, under that conditions, we may think of reactor starter. Okay, so under normal practical applications, preferably we don't go with reactor starter, though it is lossless, but its cost is high. Okay, because losses only in starting, no resistor starter. Okay, so reactor starter will not be used in practice, most preferably. Now next thing is, basically, though in some books they have given reactor starter and some faculties say reactor starter and all, reactor starter will not be there in practice, because reactor is nothing but transformer only, no? Okay, so reactor is nothing but transformer only. For example, this is the transformer, okay, or this is the reactor. Okay, so this is the reactor. Now okay, let me try it again. Okay, so for example, this is the reactor, okay. Now you should have taps, no? So for example, taps are here, so common point is here. What is this? Auto transformer only, no? Okay, so the tabs has to be changed. One thing I'll tell you, there will be no reactor starter at all in practice. Only auto transformer starter will be there. Okay, so the moment some books, some faculties may say that no, reactor starter will not be there. Okay, only auto transformer starter will be there. So the idea of this is wrong, big wrong. Okay, only resistor starter will be there, next auto transformer starter will be there. Okay, so in auto transformer starter, let us see auto transformer. Okay, this auto transformer star point. Okay, and from here let me take out tabs, and this you please give it to A, B, C. Now you please give it A here, you please give it B here, you please give it C here. Okay, so now this is going to be auto transformer starter. Definitely auto transformer starter is costly. Okay, definitely it is costly, means that default we have to use for high capacity machine. Okay, so high tension motors we say, HT motors we say. HT motors in the sense very simple, like in interviews also, some interviews they will ask what is meant by HT motors. Normally 440 volts will be the three-phase supply available to consumers. Okay, for example, directly we can take at 5.5 kV. Okay, so primary level distribution, so 5.5 kV motors will be there. Those motors are called HT motors or high tension motors. Okay, now for high tension motors or high capacity motors we can use this, because auto transformer again everything will come. Okay, now see here, let us think of, I supplied rated line voltage here, so after the tabs is going to be X times rated line. Okay, now for example, if I think of it is connected in star. Okay, why always I'm considering it in star only? You will come to know in star delta starter very soon. So it is going to be X times, X is the reduction factor, though that much percentage it got reduced because of auto transformer. So this is going to be X times rated voltage phase. Now X times rated voltage phase, voltage is reduced, means that my current is going to be X times rated current, short circuit current, SC, X times ISC. So current output here is X times ISC. Now which is HV, which is LV? This is HV, this is LV. Voltage should be reduced in order to reduce the starting currents. So means this is HV, LV. LV side current to HV side current. LV to HV voltage will be increased and current should be reduced. So this is going to be X square times ISC. Okay, so as I told you, my starter purpose is to protect the source current or line current is this. Okay, in our previous session we solved problems also, means they can ask line current or they can ask motor current. So motor current also they asked, we have done problems. Line current also they asked, we have done problems. Of course in DOL starter only they asked till now. And like for these anyway, as I told you, like 3 questions they have given. 3 questions they have given in 1 year. Okay, now let us think of T starting by T full load is going to be I starting by I full load square into SFL. So I starting is how much? X times reduce, no? Phase current, starting torque, phase current should be taken. So phase current is X times, so this is going to be X square ISC by IFL square into SFL. Okay, so means what has happened, what is the conclusion here? In autotransformer starter, my current is reduced by X times in motor, so torque production is reduced by X square times. Now source current is also reduced by X square times. For example, voltage is reduced by 50%, torque is reduced by 50% square to 25%. Source currents are also reduced to 25%. It's an advantage, no? So starting torque, whatever is reduced in the same percentage, my source current is reduced. The moment its source current is reduced, what will happen? Sudden demand of reactive power will be reduced. Means that my source voltage dip will be reduced. Okay, now let us think of the most beautiful thing, that is star delta starter. Okay, let me ask you before starting star delta starter. Okay, what do you say, most of the cases induction motor most probable connection. Okay, for example, normally alternator should be connected in star. It has its own advantages, we will see in detail course, but at least for the time being, let me tell you why most of the induction motors preferably are connected not in star but in delta. Okay, why? Because combination of starter and motor cost will be reduced, price will be reduced. Okay, so preferably we connect our induction motors at least medium level, from medium level, may not be very small motors, from medium level I can say. Okay, it means preferably they are connected in delta because we can use star delta starter. Okay, for example, let me tell you, if you think of autotransformer starter, you have to go to the market and such a huge thing you have to buy, which costs us. For example, resistor starter, you have to go to the market and you have to buy resistors. For example, star delta starter, what you are going to do? Same machine, first you are going to connect it in star and after that you are going to connect it in delta. But in order to use star delta starter, machine is supposed to be designed to be in delta. Okay, so if the machine is designed to be in delta, then only I can use star delta starter. So star delta starter in the sense it's a switch only. It's nothing like resistor inclusion or nothing like auto transformer inclusion will not be there in the network or in the system. Okay, so only connection change. Okay, so only it's a switch. So combination of motor plus starter, that is switch, is going to be reduced. That's why preferably our most of the induction motor, at least medium level induction motor, will be connected in delta. Okay, now let us think of star delta starter. Okay, so in star delta starter, for sure machine should be connected in, designed to be connected in delta, Okay, so for example, for comparison, for example, machine is designed to be connected in delta. Okay, so my machine is designed to be connected in delta. Actually, some guys focus on the switch, how it is connected in star, how it is connected in delta. Not required, because the diagram cannot be asked in the exam. Okay, for example, if a machine, delta connected designed machine, if you directly connect it in delta with DOL starter. Okay, so with DOL starter in the sense, okay, so if I directly supply rated voltage line, so this is going to be rated voltage line, so this is going to be rated voltage phase is nothing but line, so this is going to be ISC per phase, ISC in phase, so this is going to be √3 times ISC, so source current is going to be √3 times ISC. Okay, for example, somehow by using a small switch here, okay, somehow if I can connect this delta in star, what will happen? For example, machine connections are connected in star, Okay, so output side, like input side, you did not change anything. So if I connect it in star, same line voltages. Okay, so for my source will not come to know, like the connection of the machines. So for example, rated line. Okay, so if rated line voltage is supplied in star, how much will be this voltage? V rated phase, for example, this phase voltage by root 3, no? Okay, so by root 3. Okay, so for example, okay, let me tell you in this way. For example, this line voltage is 400 volts. 400 volts, and it is supposed to be connected in delta. It is designed to be connected in delta. So if I directly supply 400 volts here, okay, ISC will flow here. Okay, ISC will flow here. Line current is going to be root 3 times ISC. Root 3 times ISC, problem solved. Now for example, input side, this is same, but inside some connections are changed such that we connected this in star. Okay, so you supplied 400 only now. So how much will be the phase voltage? 400 by root 3. 400 by root 3. So if 400 is supplied, this is ISC. If 400 by root 3 is supplied, this is going to be ISC by root 3. So this is going to be ISC by root 3. Now if you compare DOL starter and if you connect it in star, then what is the difference here? If you directly connect it in DOL root 3 ISC, if you connect it in star ISC by root 3, so what is the variation? By 3. Okay, so my starting currents in line reduced by 3 times in the source. Now let us think of inside phase currents. Inside phase currents will give you the torque. Okay, so let me do, torque developed here, starting torque by full load torque equal to starting current by full load current square into SFL. Okay, so how much is the starting current phase? Because phase currents will produce the torque. Okay, so if you directly supply, it is ISC. If you connect it in star, ISC by root 3, ISC by root 3 square will give you 1 by 3. 1 by 3 into ISC by IFL square into SFL. So what's happening here? If you connect at starting only, if you design to be working with the delta connection machine, if you connect it in star first for time being, then what will happen? Because of this, because of ideally this is supposed to be the connection, but because of change in connection, starting torque is reduced by 3 times. Because of change in connection, line current, source current is reduced by 3 times. Okay, what does it mean? It is like autotransformer starter only, no? Okay, so in autotransformer starter, for example, what is happening here? Starting torque is reduced by x square times. And this is also reduced by, source current is reduced by x square times. So we can directly say that means my delta starter and autotransformer starter are same, but here with the turns ratio of 1 by root 3. Okay, so if I have tapping of 1 by root 3, X is going to be, in the sense, voltages are reduced by 1 by root 3 times, currents are reduced by 1 by root 3 times, torque is reduced by 1 by 3 times, source current is reduced by 1 by 3 times. So star delta starter is equivalent to autotransformer starter with the tapping of 1 by root 3. Okay, now if you see, whatever the advantage we are getting by huge investment of money of autotransformer starter, we are just getting by changing the connections. Okay, so this is going to be star delta starter. Now let us solve problems on this. I told you, 3 problems they have given, each 2 marks, 6 marks, only from starters, very simple concept. 3-phase squirrel cage induction motor has starting current of 7 times full load current and full load slip of 5% they have given. Okay, actually starting currents of 7 times full load current, in our terminology, that is ISC. Okay, so ISC is going to be 7 times full load current, and what they are asking, if an auto transformer is used for reduced voltage starting to provide 1.5 per unit starting torque, the auto transformer ratio should be. Okay, so means they are saying starting torque in per unit. Okay, starting torque in per unit, in this is with respect to rated torque, a full load torque should be How much they have given? 1.5 per unit. It should be 1.5. For that, already we know that, like, Autotransformer Starter, x square. So x square into ISC by IFL square into SFL. Okay, so this is going to be x square into ISC by IFL is 7 square into SFL is 5%. Calculate x. Okay, so if you calculate x, that is nothing but x into 100 is going to be percentage of auto transformer, like transformation ratio. So if you calculate that x came down to 78.246%. Okay, 78.25%. Now next thing is, for the same question, same common data, for the same data, if star delta starter is used to start this induction motor, the per unit starting torque will be. So starting torque per unit with respect to rated should be equal to x was how much? Just now we have seen, like in our recent video, that is going to be x is going to be 1 by root 3 or x square into I starting or ISC by IFL square into SFL. So is going to be 1 by 3 into ISC is 7 with respect to IFL. So 7 square into 0.05. So starting torque we got 0.8166. 8166 per unit. Okay. So 0.8166 per unit. Now, like in induction motor, the per unit starting torque over. Now let us think of one more question. If a starting torque of 0.5 per unit is required, then the per unit starting current should be. Okay. So for example, starting torque of per unit should be equal to 0.5, should be like x square into ISC by IFL square into SFL, or x times ISC by IFL square into SFL. Okay, so how much will be the starting current in per unit? X into ISC is nothing but starting current. So TST by TFL is 0.5 equal to x times ISC, or directly I can write IST starting current divided by IFL square into SFL is 0.05. Okay, so IST by IFL is going to 0.5 by 0.05 is going to be 10 under root. Okay, 10 under root is going to be 3.1622. 3.1622. Okay, so IST with respect to full load is nothing but starting current in per unit is going to 3.1622, 3.16. Okay, so very short problem, like 3 questions we can solve in 3 minutes, but 6 marks. Okay, sometimes questions will come this way also.